All right, so our last section we're going to look at this week is same part, okay, same section, just part 3. So yesterday we found the trig functions of the angles that were 30, 45, and 60. So in other words, we were always in quadrant 1. Today what we're going to do is move into other quadrants. So we're going to look at angles that are multiples of 30, 45, and 60. Okay, and of course there's some overlap there, because if something is a multiple of 60, like 120, it's also automatically a multiple of 30. Also, some multiples of 45 and 30 overlap, like 90. 90 is a multiple of both. So there's some overlap here, but that's in general what we're going to try to do. And then the very last thing we do, as I mentioned, we'll look at the calculator and see if we can figure out how do we type in angles that we can't do on the unit circle into the calculator. So we're still using the two triangles we learned yesterday, the 30, 60, 90, and the 45, 45, 90. Okay, only difference is now the triangles aren't always going to be drawn in the first quadrant. Okay, so as far as explanation, like for this part, that's it. Okay, we're just going to do some different examples and use what we already know to do it. All right, so let's start with finding the 6 trig functions of 135. Okay, so first thing you have to do is figure out where it is on the circle. So 0, 90, 80, and 270. So where is 135 on that circle? Yeah.
Halfway between 90 and 180.
Yeah, it's halfway between 90 and 180. If you wanted to get it, kind of perfect, you could, say, like bring up a protractor. I'm not going to do this for every problem. Yeah, on-screen keyboard is going to take a while. P-R-O-T-R. Let's see if it finds protractor. Well, that's a picture of a protractor, but I'm not sure I can actually use it to do anything. It's, well, I guess the protractor is not going to come up. Let's see if I can actually draw anything with that. No, that's just a picture. But if I had a protractor that actually worked, I could draw a 135-degree angle. It would look something like, maybe about like that. And you would draw it inside the circle. And really, the only part that we care about is the part that I'm leaving, okay, in red. That's where the terminal side would hit the edge of the circle, exactly halfway between 90 and 180. Now I have that side. What else? What shape did we draw yesterday when we were doing this? Yeah, a triangle. So we're going to do the same thing again. I'm going to draw my vertical. Always draw it perpendicular to the x-axis. And now I need to figure out what kind of triangle I have there. Is this triangle the 45, 45, 90, or the 30, 60, 90? Which one is it? Yeah, Alex?
45, 45, 90.
Yeah, it's the 45, 45, 90. And the way I know that is because if I look at the difference between 135 and 90, I've gone 45 degrees past 90 to get to 135, which means this section is 45. This whole section makes a 90. So that means this section on the inside also has to be a 45. Okay. Any questions on how we know that? Okay, so that's 45. That's a 45. And now from here, we just label our sides. Peter, what's the length of each side in a 45, 45, 90? And let me clear that, actually, each leg. Each side is root 2 over 2. So if you were to take a ruler and measure them, they each would come out to root 2 over 2. But we have to be careful when we write our coordinate. Keep in mind that we are in quadrant 2. So Haley, what do you think the coordinate would be for 135? Careful, that's positive, positive. That would be in quadrant 1. Negative, positive. So negative root 2 over 2. Positive root 2 over 2. Okay, and as far as what we're doing today, that's the only difference. Sometimes there's a negative with x, sometimes it's with y, sometimes it's with both. Depends on the quadrant. Any questions on how we got that as our coordinate? Okay, now we just fill it in just like always. Okay, so we'll start with the sign. Okay, Eric, what would be the sign of 135?
Root 2 over 2.
Yep, the y value, which is root 2 over 2. Paige, the cosine?
Negative root 2 over 2.
Okay, negative root 2 over 2. And Molly, what about the tangent? Yeah, exactly. Because when you do the tangent, you're taking y divided by x. Well, y and x are the same, except one of them has a negative in front. So if you divide two numbers that are only different by a negative, you get negative 1. Okay. How about Alex? What would my cosecant be?
Negative, 2 over root 2.
Yep, it would be 2 over root 2, which would then simplify to...
2 root 2 over 2.
Yep, 2 root 2 over 2, which would simplify even further to just root 2. Good. And the only reason I asked that is because if it's a question on the test, like if it was a multiple choice matching up, you're going to see it written properly. There won't be any roots in the bottom as a correct choice. All right, and Robin, how about the secant of 135?
Negative root 2?
Yeah, because sine and cosine are only different by a negative. Cosecant and secant are only going to be different by a negative as well. And last one, the cotangent. How about Emily? Can you tell me cotangent 135? Yeah, it's also negative 1. Okay, so any questions on the 6 trig functions for 135? All right, and there's 2 other quadrants we can do 45-degree angles in. Well, we'll review this one. We did that one yesterday. We can do that one down there, which is 315. It's halfway between 270 and 360. And then we can do this one over here. What do you think is halfway between 180 and 270? Yep.
They both be negative root 2 over 2.
The coordinate would both be negative root 2 over 2. And what would be the angle represented by that coordinate? 225. Yep. So 45, 135, 225, 315. Those are your 45s. This is the only problem we're going to do today where we do all 6. Every problem from here on, we're just going to pick one trig function to do. Okay, so like this problem will be cosecant, the next one will just be sine, and so on. Okay, if you don't need to draw the diagram every time, you don't need to. Okay, that's fine. But you do have to figure out the coordinate for this somehow. Okay, anyone think they know the coordinate for pi over 4? Yep, Peter?
Is it root
Yeah, can you explain how you knew that was the coordinate?
Because 180 divided by 4 is 45 degrees.
Yeah, so in his head, he just changed radians to degrees. That is a 45-degree angle. And from here, that's one of the numbers you just have to memorize. Root 2 over 2, root 2 over 2. Okay, now they want the cosecant. So how about Connor? What letter do I flip to get cosecant?
What?
Yes, you flip the y. In this case, it doesn't really matter since they're the same. But what do you get when you flip root 2 over 2 for a final answer? Root 2. Yep. That's how a problem on the test will be. Give me the coordinate, give me the final answer, and that's it. Okay. Any questions on that? Okay, so that's kind of a review from yesterday. 225. Okay, we just talked about that angle. That one is halfway between 180 and 270. So the first thing you have to figure out is it a 45-45-90 or a 30-60-90? Well, if it's halfway between 180 and 270, it has to be which triangle? Yeah, it has to be the 45-45-90. So, anyone think they can give me the coordinate for 225? Yeah. Yeah. Negative root 2 over 2. Negative root 2 over 2. Sorry, I said it correct, wrote it wrong. And then negative root 2 over 2. Okay, so that's half the problem, getting the coordinate. And now, Faith, what about the sign? Negative what? So what? Do you remember what's the formula again for sign? Yeah, just the y value. So what's the y value here? So it's negative root 2, but it's also divided by 2. Okay. Any questions on that one? All right, let's try cosine of 7 pi over 4. Matt, what might I want to do first?
Convert it to degrees.
Yep, and how do you do that?
You multiply it by 180 over pi.
So multiply by 180, divide by pi. The pi's are going to cancel. So really it's just 7 times 180 divided by 4. I get 315. All right. So Ileana, what kind of triangle, or you could also say 315, is that a multiple of a 45 or is that a multiple of 30? That's a multiple of 45, yeah. And can you tell me what quadrant 315 would be in? Yeah, it would be in the fourth quadrant. Here's 270, here's 360. Would it be closer to 270, closer to 360, or right in the middle? Yeah, 45s are always right in the middle. So there's your 45, 45, 90. And now we need the coordinate. Coordinate for 45s are a little easier to come up with because you don't have to remember the order. They're both root 2 over 2. Bless you. When we do the 30s and 60s, then you have to remember the 1/2. Does it go first or does it go second? That's where the picture helps more. Okay, but we don't need it as much for the 45s. So Mason, what's my coordinate for 315?
Root 2 over 2.
Yep. So there's your coordinate. And Orion, what would be the cosine?
Cosine would be square root of 2 over 2.
Yes. Cosine is just the x value, which in this case is root 2 over 2. So the negative kind of makes a big deal. So if you accidentally put negative root 2 over 2, that's totally different. That's the sine, not the cosine. Okay. Any questions on that one? Okay, so now we've done a 45-degree angle in every quadrant. Okay. Let's try tangent of 120. Okay, Ashlyn, what do you think about this one? Is this one going to be having to do with the 45-45 or the 30-60?
I'm going to say 30-60.
Yeah, this is going to have to do with the 30-60. Okay, because 120 is not a multiple of 45. Okay? So let's see if we can sketch where 120 would be. Okay, Alex, 120. So I know it's between 90 and 180. Right in the middle, closer to 90, closer to 180. It's closer to 90. Okay, the 30, 60, 90 triangles, you do not draw them right in the middle. So let's put 120. I might be exaggerating it a little bit, but maybe about like that. Okay, I'll move it a little bit. All right, so make your triangle. Okay, so I got my triangle. And now there's two numbers I have to remember. Can anybody give me one of the two numbers that has to do with this triangle? Yeah, Zach?
Negative root 3 over 2.
Don't worry if it's going to be positive or negative yet. Root 3 over 2. Is root 3 over 2 the long side or the short side? It's the long side. Okay, and if I've drawn this accurately, I can tell my long side this time. Is it the height or is the long side the base? It's the height. So the long side is the root 3 over 2. And how about Haley, the short side is how long? It's 1/2. Now we're going to worry about positive, negative. Okay, so when I write my coordinate, Eric, should the 1/2 be positive or negative? Negative, because we're going to the left. And Paige, the root 3 over 2, positive or negative? Positive. And that's basically the process you go through every time to figure out where the 1/2 goes, where the root 3 over 2 goes, which one's positive, which ones are negative. Okay, so now tangent. Molly, how do I find the tangent?
You divide the y and x.
And which one do you divide by which?
Well, no, y is on top.
Y is on top. So take y, divide by x. Robin, if I divide that, what cancels out? The 2's. And all I'm left with is root 3 divided by negative 1, which is negative root 3. Any questions on that one? Okay, so I've shown you guys how to do the 45s and the 30s. Why don't you try one on your own? See if you can figure out the secant of 690. All right, so as we go through it, first thing you want to look at, if it's not in degrees, usually we like to put it in degrees. Okay, it's already degrees. Second thing, if it's too big, what can we subtract to make it smaller? 360. So if you subtract 360 one time, that's enough, and you get 330. Now, is that a multiple of 30 or 45? Multiple of 30. So this would be 270. Now, this is 0, but it's the same as 360. Goes all the way around. So 330 is maybe about right there. It should be closer to 360 than it is 270. Any questions on why I put that there? Because that's going to be the whole key. Now when I make my triangle, you should pretty clearly, well, it's kind of the same color on top of the circle, but you should be able to see which side is the short side, which side is the long side. So here, how about Alex? Where's the short side in that triangle?
Short side is the negative going down.
Yeah, it's the part that's going up and down. It's the vertical. And the short side is always how long? A half? I'll worry about what he said about negative in a second. And Emily, what about the long side? How long? Root 3 over 2. So now I know the x-coordinate has something to do with root 3 over 2. The y-coordinate, something to do with a half. We just got to be careful with negatives. So how about Cameron? What would be my coordinate for 330?
1/2 root 3 over 2.
In that order? 1/2 root 3. The other way around? Closer. We got to be careful with something though, because of the quadrant.
Negative.
Negative? All right. So you want to say the whole thing for me again?
Negative root 3 over 2. 1/2. Or 1/2, sorry.
Not quite. You want to help him out? You're close, but we got to get that negative in the right spot.
Root 3 over 2.
Yes. The root 3 over 2 is positive because you're going to the right. That 1/2 is negative because you're going down. So that's your coordinate. And now the secant. So Alex, what's the secant again? What's the formula for it?
1 over x.
1 over x. So we got to take the x value and flip it. And when I fix that, Mason, what will I get?
2 root 3 over 3.
Perfect. 2 root 3 over 3. Yep. Great. Any questions on that one? Okay. Does anybody want to see how to do this one? If we do, we can do it. If not, we're going to move on to something else. But does anybody want to see this one? Okay. If you were going to do it, what would be your first step? Yep. Change degrees. Then what would you have to do based on just looking at what kind of number it is? Yeah? Yeah, you're going to have to add 360 to it at least once. Okay? And then from there, you would draw your triangle, find the coordinate, and then once you get the y value, flip it. So any questions on how to do that, or if you saw one like that on the test, what you would have to do? No? Okay. So I'm going to show you kind of a summary of everything we've done. Now, it's going to look a little complicated at first because it's going to draw every single triangle for every single problem you could have all on the same picture. Right? But if you go through it, it's really a lot of repeats. Right? So all I like to do is focus on quadrant 1. The red triangle, that's my 45, 45, 90. And then the green and the blue are my 30s and 60s. So as long as you remember those three, everything else is the same numbers. Except sometimes you put a negative a half. Sometimes it's negative on both. Or sometimes it's just a negative on one part of it. Right? But every other number on this circle is a repeat of the three that I just circled. The other ones that are special are the ones we did the very first day. 0, 90, 180, and 270. Okay, I wouldn't try to memorize every single angle with every single coordinate. I just don't think that's the best way to go about it, because you can just remember the first three, make a sketch, and figure it out from there without having to memorize everything. If you're really good at memorizing and you can memorize every single angle and every single coordinate, I guess you could, but I just don't think it's worth it. Okay, so in terms of this, there's basically, let's see, 3 angles in each quadrant and 4 that are on the axes. So there's 16 different angles that I could ask you about on this circle. And for every angle, there's 6 trig functions. So that gives me 96 different questions I could ask. What's the sine of this one? What's the tangent of that one? What's the cosecant of that one? Okay, things like that. And we've answered a lot of those questions in class. We haven't done every single possibility, but we've done a lot of them. Okay, so any questions on that? So there's your unit circle. All right. All right, let's take a quick look at this. This question would be something you might see as as a bonus. Okay, I may put something on with a bonus with this question. So let's say that you had a triangle, and I'm going to put it inside the circle like we always do. Except this triangle is bigger than the unit circle. Okay? Let's pretend that this is the unit circle. So it's 1 unit from here to here. That's 1 unit. So that green triangle is definitely on a bigger circle. How big is the circle? I don't know. It's bigger than 1. Maybe it's 5, maybe it's 6. The point is it's R. Okay, we'll call it a radius of R. Now, here's the same, a similar triangle. Okay? It has the same kind of slope for the hypotenuse, but it's a smaller version of it. Okay? If I were to drag it and make it bigger, you would see that not that big, but you would see it would line up perfectly. It's the exact same triangle, just kind of shrunk down. Okay, so any questions on that? All right, so if this part from here to here, from here to the origin, is R units, I don't want it to be R units. I want it to be 1 unit. I want to think of this green triangle shrunk back down so that the hypotenuse is back to 1 unit. I don't want it to be R units long. So let's think of it this way. Pretend the green triangle had a radius of 5. Okay, pretend it was 5 units long. What would you have to divide that by to turn it back into 1 unit long? Yeah? Not 0.2. That would make it 5 times bigger. You could multiply by 0.2 or divide by? No, not 20. So if your radius was 5, and you wanted to scale that triangle back down so it was a radius of 1, what would you scale your triangle by to make it have a radius of 1 again? Yeah? You would scale it down by 5. You divide it by 5, or you could say multiply by 1/5, which is 0.2. What if your radius was 10? So the green triangle was 10 times too big. How would you scale it down to make it so it was a radius of 1 again? Rudy? Has a radius of 10. You want it to have a radius of 1. So what would you scale it by? Yeah, you divide it by 10. Okay. Alex, what if my radius was 37 and I wanted to make it a radius of 1? What would I scale the triangle by? 1 over 37. I would divide it by 37. Now, what if the radius is R? would I scale it by to force the hypotenuse to be a 1 again? What's the pattern here? Yeah? Dividing it by itself. So if the radius is r, you would divide by r. And that's the whole key. If you ever have to do a problem and you have a triangle that's too big, you can't use this for sine anymore, because that assumes that you were using the red triangle, where the hypotenuse was always 1. But what you can do is divide it by r. You basically divide everything by r. So in your formulas, everywhere you had a y, instead of using a y, use that. Everywhere you had an x, can't use x anymore, divide it by r. So what you're doing by dividing it by r is you're turning the green triangle back into the red triangle. It's like you're scaling it back down, so we can think of it as being on the unit circle. But if you scale it, you do have to keep in mind it's not y anymore. You scaled it down, you divided by r. Okay, so what that does is it gives us formulas for unit circle trig, well, actually general formulas. Okay? Not just on a unit circle, but on any circle. The radius could be 1, like it has been all week, but now the radius could be 6, 15, 762. As long as you use these formulas, it would work. So notice what sine was y. You scaled it by r. So now it's y over r. Cosine is x over r. But look at tangent. Did anything happen with tangent? No. And that's because if you think of tangent as y over r divided by x over r. Okay? I change y to y over r, change x to x over r. What cancels out there? The r. So with tangent and cotangent, there's no difference in the formulas. What do you think the cosecant would be? Rudy? R over y. How about the secant? Yeah? R over x. And the cotangent, I already told you, stayed the same. X over y. So these were really the formulas I taught you on Monday. The only thing that I did on Monday is I always let r equal what number? 1. And I didn't tell you that. So if r is 1, don't erase it on your paper. I'm just showing you here. Sine becomes just y. If r is 1, cosine becomes just x. That becomes 1 over y, and that becomes 1 over x. So the formulas I gave you were actually a special case, the easiest case, when r is a 1. Now, you know the general formulas, so r can be anything you want. Okay, any questions on those? So let me show you kind of bonus question you would have. And r is the radius of the circle, but I think I already mentioned that. Okay, let's find the sine, the cosine, and the tangent of the coordinate 5, 12. Now, if you drew a circle, okay, and I put a grid on it, that's as best I can do by hand. That's a unit circle. It goes 1 unit in each direction. If I go 5 units to the right and 12 units up, is it going to be on that circle? No, it's way off it. Okay, it's like way up here somewhere. So that point is not on the unit circle. So in order to do the sine and the cosine, you still need to know x. You still need to know y. But what other letter do you need to know now? You have to figure out r. Okay, so let's, it doesn't have to be exact, but let's just pretend we go right 5, up 12. Okay, something like that. We go up more than we go to the right. Okay, I'm going to make a radius, make my triangle. How long is the bottom side from here to here? 5. And what about the height from there to there? 12. And that's the radius. So how could you figure out the radius of that circle? Yeah? Yeah, we just do the Pythagorean theorem. R squared equals 5 squared plus 12 squared. 5 squared gives me 25. 12 squared, 144. If you add those up, you get 169. And then take the square root of 169. So what's the radius in this circle? 13. Now you know R, you know X, you know Y. Just fill it into the formula. So Peter, what's our formula for sine in general? It's y over r. What's y in this case?
12.
And what's r? 13. That's it. There's my sine. Haley, what's the general formula for cosine? X over... if it's a unit circle, but what if it's not a unit circle? X over r. What's x in this case? 5 and r? 13. Good. 5 13ths. And lastly, Eric, formula for tangent?
Y over x.
Stays the same. So my tangent would be 12 over 5. Okay, so doing the same type of thing we were doing on a circle that's not radius 1, it's not really too much harder, but there is the extra step of the Pythagorean theorem to find the radius. That's the only kind of problem you would see like this on the test. Okay? I would give you the coordinate, and you would have to use the Pythagorean theorem to find r, and then plug it in from there. Okay. Any questions on that one? Okay, so last thing we'll look at is on the calculator. Yeah. So we've used unit circle trig to find sines, cosines, all that stuff, but the angle had to be a multiple of 30 or 45. Now, if you wanted to do like multiples of 15, technically there is a way to do that if you know the 30s and 45s. But it's not something we look at in trig. So anything that's not a multiple of 30 or 45, you're going to use the calculator. So I'm just going to show you how to type it in. Can someone read to me what does that say? What is that problem if you read it out? Yes.
Sine of 18 degrees.
Yes. So the last word that you said is very important. Sine of 18 degrees. So if I'm using my calculator, the first thing I want to do is make sure that it's in degrees. Okay, so if you're doing it on a graphing calculator, you press mode, and then there's a choice for degrees and radians right up there. If you're using a scientific calculator, there's a button at the top that says DRG. If you press that, you have a choice of degrees, radians, and I think there's a third choice, gradians. We don't use those in this class, but you could just use the arrows and select. If you have another calculator like Casio, it might be a little bit different. Yeah, I'll have to come over and help you figure it out. But I'm going to make sure I'm in degrees. Okay, now to type it in, on my calculator, you press the trig function first, then you press 18, close parenthesis. So I pressed the trig function, then I pressed 18. On this calculator, the one that comes with the computer, it's backwards. I press 18, and then I do the trig function last. Okay, if you have like a scientific one, the ones that I have, you do it like I do on the graphing calculator. You type it in the order you would read it. Okay, I don't really like this calculator as much because you have to type it in backwards. Okay, 0.309, that's what you should get as an answer. Okay, how many people got 0.309 if you tried it? Okay, good. If you got something like this, negative 0.75, did anybody get negative 0.75? No? If you did, it's because your calculator was in the wrong mode. You were in radians. All right, let's try cosine of 356 degrees. Robin, if I'm already set up from my last problem, do I need to change my mode here? No, it's already in degrees from last time. Okay, so just leave it. Cosine 356. And Victoria, what did you get when you typed that in? 99. And let's round it off to 3. What would you get if you round properly to 3? Yes, 0.998. Okay, so there's the cosine of 356 degrees. Tangent of 2.4. Okay. What should I do first on this one? Yeah, Emma?
Put it in radians on the calculator.
Yes, I need to change to radians because they did not put a degree symbol. They're not going to tell you in parentheses, keep in mind this is radians. You just have to know. There's no degree symbol, change to radians. And now, type it in. Tangent, 2.4. So you should get negative 0.916. Okay, so any question on sine, cosine, and tangent? Doing it in radians or degrees? All right. I want to find the cosecant of 247 degrees. What's the first thing I should do here? Yep.
Go back to degrees.
Yep. Go back to degrees. And now, does the calculator have a button that says CSC? No. So the way you have to find it is exactly the same way we've been finding it all week. How do you find the cosecant? What do you do first? Find the sine first. Yeah. Okay. So there's the sine of 247. And what do you do with that? Flip it. Yeah, take that number and flip it. So you can either type in 1 divided by on your calculator, or I have a button that raises things to the negative 1 power, so it flips it for me automatically. So you find the sine of 247 and then flip it. However you can flip it on your calculator. It's a negative 1.086. All right, how about page secant of 6? What would I do first?
Change the calculator to radians.
Good, change to radians. And how do you get secant of 6? Do the what of 6? Yep, do the cosine of 6 and flip it. I'll show you another way you can do it. If you don't want to have to flip it in the end, type it in just like that. 1 divided by cosine 6. Okay, 1.041. Okay, and last one, cotangent of 13 degrees. All right, Matt, can you tell me what I should do for my first step? Yep. My calculator tells me I'm in radians at the top, so I don't forget. Go back to degrees. And how would I get cotangent of 13?
You get the tangent above that.
Yep. So I'm going to do that, what he just said, all in one step. I'm going to find the tangent and flip it all at the same time. Okay, so 4.331. Any questions on that one? Okay, so again, plan tomorrow. We'll review, go over the homework. I'm going to give you a few problems to try in class, work in groups. I'll walk around, answer any questions. Last 25, 30 minutes of class, we'll start the test. I'll be after school for extra help tomorrow if you need to come see me. And then we'll finish the test on Friday. Okay, so homework, same page as you did on Monday night. It's 49 to 57 odd. 67 to 81, that's all. And those are all calculator questions. So you need a calculator for every one of those. Just type it in and that's it. And then 83 and 84, those are the ones we did with the y over r, x over r stuff.